What's going on, guys? In this video we are going to take a look at differential amplifiers. Now the first here we are going to look at the bypassed C. Okay, now here what we are going to do is first we are going to look at the circuit, then we are going to do the DC analysis. By doing DC analysis, what we get is we get the IB current and base current and also collector current IC. Then we do the AC analysis. This whatever the value we found out in DC analysis like IBIC, it's going to help us to find out GMV5. Okay, now first of all let's go ahead and create the input voltage equation. To do that we can create a simple circuit from this like this. You can apply KVL to derive the equations. This is V input and this is our RE, and this is emitter, this is collector, this one is base. Okay, RE connected to the ground, and from this one you can derive an equation for V input. That one is, if you apply KVL, you will see VCC times R2 divided by R1 plus R2. You have to apply KVL right here. Okay, this one actually voltage division, like VCC R2, across R2 we have V input, so R2 on top, R1 plus R2, this input voltage. Now for the next thing we are going to calculate R input. R input is R1 parallel R2, R1 parallel R2. Now for this one we have to use the KCL. IB is equivalent to V Thevenin minus VBE divided by R Thevenin plus 1 plus beta times RE. Okay, this is IB current. Now next thing is we are going to calculate IC. IC is equal to beta time IB. Now here we calculated IB, this is IC. Now the next thing is we are going to do the AC analysis. To do the AC analysis, first we are going to draw the circuit. Okay, here we go. The voltage across here is V output, and then the resistor here is R load, and this one is RC, and this one is collector. Here we have emitter, this one is base, and this is RS, and here we have R Thevenin, and this one is R5, and the voltage across R5 is V5. Okay, and then here we have VS. Now here we have Z in, ZI, Z. This one is ZB, and this one is the output impedance ZO, and here we have ZO prime, RCVO, and then that's it for this one. Now let's go ahead and calculate the input impedance. Input impedance, that is CB is equal to R5, ZI is equal to R in parallel R5, and then Z in is equal to RS plus ZI. Then output impedance that is ZO is equal to RC and ZO prime is equal to RC parallel RL. Then second one, GM is equal to IC over VT, that's equal to IC divided by VT is 26 times 10 to the power minus 3. R5 is equal to VT over IB. AV is equal to VO divided by VI, this voltage gain. And let's continue here. Instead of VO, AV is equal to VO divided by VI. VO and VI, okay, let's plug the values. VO is basically the current times the resistance, parallel resistance. GM, negative GM by V5 times RC parallel RL divided by V5. Here you can see V5 cancels, so the gain will become negative GM RC parallel RL. And finally we can write it as AV times ZI over ZN. AV is equal to AV times ZI over ZN. That's what we can derive from AC analysis. Now from this one you can see, first we do look at the circuit, then DC analysis. From DC analysis we found out IB and also IC. IC is beta times IB. Then we go to AC analysis and we find out the GMV5. Okay, and that's it for this one. I have a bunch of videos on these topics, and also if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch it too. Don't forget to subscribe. See you next time.